joining this workshop. So for those who don't know me, I'm Mohamed Zouari. I'm the head of R&D and make-or-buy strategy for Framatome business unit, PCM, it's project and component manufacturing. This business unit mainly deal with designing and manufacturing the new builds project, EPR, and maybe in the future, small modular reactor and vast modular reactor. So today we'll be discussing additive manufacturing and nuclear industry at the age of additive manufacturing. I think it's a nice topic. Everyone has been hearing about this. So let's see what where we are, where we stand, okay? So additive manufacturing. I have put here some pictures from the public information, but also from partners. Huh? So in the, I don't know. So I have put some picture here to show where is the additive manufacturing. So basically, at the left side, these two pictures are from MX3D. I don't know if you know them, and they're from Netherlands. They're quite good. So there's a bridge, actually, that has been printed in Amsterdam. Okay, and here you can see also an impeller that has been printed for power plants, basically. And then on the right side, there is some picture from Nikon SLM Solutions, basically showing how big could be the component that they have. Here is space application component, is aeronautic, and this is an example what is the next generation of the what will be printed by additive manufacturing. So this additive manufacturing is really drastically changing the industry today. It's really accelerating in the other industries. We see it in automobiles, in space, in energy, and the capacity of manufacturing are increasing. So, but how about the nuclear industry? You know, it's a safety classified industry. Where we stand, where we're going, well, and this is what we'll be seeing together today. Okay. So next slide. So I have divided my presentation in 3 parts. So the first one will be taking a look on what we do in additive manufacturing within Framatome. So basically, what's our organization and what are the processes engaged. Then the second part, I will show you some of our quick benefit additive manufacturing application that is already existing. Okay, and finally, we'll end up with some perspective and added values. Okay. All right. So let's start with Framatome additive manufacturing in Framatome. Within Framatome, the adventure has started since 2007, I think, 15 years ago, and we have developed a strong background on it. And this background went quite well because we were the first of introducing additive manufacturing component in the heart of nuclear reactor. So the first time was in 2021 in the USA. This is a faster channel for fuel assembly for BWR. It has been introduced in the core of nuclear reactor under irradiation in 2021. And in 2022, we have introduced the upper tape plate grid for also BWR fuel assembly in Sweden. So we already have succeeded to take it in some industrial application. How we act in Framatome, we have developed what we call our Excellence Center for Advanced and Additive Manufacturing. This Excellence Center basically is concentrated all our effort in additive manufacturing, wherever the business unit is, fuel, INC, component manufacturing, maintenance. And this Excellence Center is mainly acting on R&D, qualification, industrialization, taking TRL up, but also manufacture component and design component with additive manufacture for our needs and also for our customers and even for some other industries. So actually what we do in Framatome, we have this combination. So Framatome, as you know, is a 65 years old nuclear manufacturer and nuclear steam supply generator designer. So we combine our nuclear know-how since 65 years with this new innovative technology that is additive manufacturing. So we have developed a unique technical content with a nuclear grade application, with nuclear grade material, with nuclear grade qualified process. And we also, as we know, nuclear industry, we have quite big component, sometimes it's 500 tons, 600 tons, 27 meters. So we have also unique capacity to make a big dimension component with additive manufacturing. And I think you have seen part of it in our stand there, at Framatome stand. So in this next slide, I'm just pointing out a picture of our major, what we call advanced manufacturing. That it has additive manufacturing and HIP on it. So basically, we have classified this component, this process, with the size, so from the smallest size to the most highest size, and with the geometry complexity, from the less complex geometry to the highest complex geometry. So basically, we deal with laser powder bed fusions, which give us the opportunity to make complex geometries. We deal also with MBG, metal binder jetting, with the plasma transfer arc, with DED, mainly lasers, but sometimes powder, also laser powder, sometimes wire, mainly wire, but sometimes powder. WAM, of course. So WAM, we make big applications, like big size applications, as you can see here. Even we have some ESPN application. And also we have the HIP, hot isostatic pressure application. This is an example of an elbow, which is ESPN application. And we have the cold spray. Cold spray for us, it's even in serial production that you can see here. So this is a TRL scale that shows where are these processes standing within Framatome. Okay, so most of them, so we have already serial production with the cold spray, and most of them are even qualified in Framatome. That means we are proposing this to our customer already, or even under industrialization. That means customer has accepted and they are under industrialization for them. And of course, yeah, so you can see metal binder jetting and DD laser. We are still evaluating what benefit we can have from it. Framatome is, or to finish this, Framatome is also working with, I think you have seen earlier EDF presentation and Solder presentation, to qualify and to make standards for nuclear application for this additive manufacturing. So we're participating to this effort. And here you can find why basically we do this, what is the usage of this application. So basically main component design, complex component design for MBG and laser powder bed fusion, on-site recoating for DED, and cold spray or PTA, and WAM HIP, we use it for large component basically, okay? Now we'll be diving in short on our short-term application, additive manufacturing. It's not all of them, but some of them that are really interesting. So I want to show you the first one. It's a laser powder bed fusion application. It's a steam generator stabilizer. Its role is to stabilize the diphasic flows, so it can help us to get a correct pressure in the steam area of the steam generator. It's an important component. We use it for handling the nuclear power plant in normal operation in an accident. It looks like this in the classical way. It's not really nice. It's difficult to, really difficult to manufacture. We have a lot of non-conformities. It's quite long to manufacture. And since we have changed our manufacturing process for the EPR with the laser powder bed fusion, it looks today like this. So it's a monoblock optimized design. It's one block instead of, I don't know, maybe, it's not all of this here, but it's a seven part component. So this is offer us, first of all, it's a RCC compliant process here for this type of component, because it allows us to use other additive manufacturing already standards that exist, so we can use them. The RCCM allow this, we can use it. It's an RTC compliant component. We are with this additive manufacturing. We enhance the quality. Actually, we don't have even a repair right now on this process. We reduce it significantly the cost on the lead time here. Even for the lead time, it's less. We reduce it by 2 the lead time, and we enhance it the installation. because we make it easier with this monoblock, and even thought for the people that would be replacing this component on site that is exposed to irradiation, they will be spending less time replacing this component, and then it will lower their dosimetry. So it's really interesting also from this point of view. So this one example, which really interested today, I have put here on a second example. I think you see this part of this application in Framatome show. So this is what we call RCP EPR reactor cooled pump impeller. It's the wheel of the pump. It handles 30,000 meter cubed per hour. It's a primary component. It's an imported component. It's an RCCM component. And it's made of stainless steel. Usually it's casted. It's casted, and it takes few years to manufacture, basically. And with the casting operation, when we take out the mold, we have a lot of repair. So basically, it's completely repaired everywhere. And we have been doing it like this since about 40 years right now. So we have introduced one wire arc additive manufacturing route for this application. So we have used the special process RCCM chapter to try to make it compatible for our EPR application. And the WAM has offered us a stable quality process. Actually, right now, unless we have two of them, and only one of them has already one repair. So basically, we have it without repair from the first time. This is quite nice. And we have drastically, and with this, we have drastically reduced also the manufacturing time. Before it was a question of few years, now it's a question of year. So this is really interesting. And what is also better is with this wire arc additive manufacturing, we have even a better mechanical characteristic than we have with the cassette material. So it's actually, we are even increasing the mechanical characteristic. It's better. It's a big item. It's a unique one. It's quite big. It's 1 meter component. It's a 2-ton component. So it's quite new. It's quite interesting, and we are really happy to show you this, to share with you this today. I have put it here two other components in another field. It's in the field of tools and temporary equipment. So the first one on the top is what we call temporary. It's a filter to protect a feed water valve. It's a feed water valve. It's a safety class valve, actually. So in Flamanville-Free, with the requalification of Flamanville-Free, Flamanville-Free has been in repair since 3 years. So there's a lot of dirt. There's a lot of things going on. So we need to protect this safety component, and we have printed this filter to catch up some delays, because the regular filter will be taken maybe 8 months to manufacture, and with this wire additive manufacturing, we have provided them for 1.5 months, which has helped us to keep the schedule of Flamanville-Free. Okay, and this is ferritic steel. It's actually quite a big one. It's 400 millimeter height. The second application here that you can show, it's an optimized welding torch for a CVS replacement. It's a quite tight area here in some installed-based nuclear power plant. And going to weld there and cut and replace the CVS nozzle there, it was quite complicated. So with additive manufacturing, we have developed a torch, a really 3D optimized torch with all items and all the feature on it, the cooling, the gas channel, pre-dimension, which has helped us to decrease the level, which was more than 20 millimeter before, to less than 10 millimeter. And this is actually was the success of the operation that we have done here. CVS could be also classified in nuclear application. So this is some of our application, but we don't do only this, we do a lot of other applications. This is few examples. So I have showed you here what we have already on site on the right part. So you have seen some of those that are in project and almost on site. But like the impeller, I didn't told you about the steam generator. It's an ESPN application with WAM. It's an addition function on the steam generator. So it's a pressure boundary retained item. We have HIP pipes ongoing. We have filter with LPBF for fuel assembly ongoing project. We have impeller that we print directly with LPBF for SMR and advanced manufacturing reactor application. And we have our new project and new challenge that you can see here. It's actually going right well. It's a reactor pressure vessel internal part. It's as big as 4.8 meter. That is all completely printed today. That will be printed and will be installed in the EPR. It's one of the biggest actually item that we can do right now in additive manufacturing. So it's 4-meter diameter. It's big. It's inside the reactor. It's irradiated. It's under vibration. And it will be in additive manufacturing in our portfolio. So it's quite nice, a nice adventure. I'm keeping going, so let's switch to the conclusion and perspective. I just want to highlight, this is for me a really important slide because it says what we earn today from additive manufacturing. So in our case, we have classified them in 5 parts. So the first one is we have reduced the cost. With additive manufacturing, we have the opportunity to reduce the cost and the lead time. And for a nuclear industry, lead times is cost, and everyone knows it. Huh? Each day, it's millions sometimes, 1 or 2 millions. So we use additive manufacturing to have less manufacturing step. It's quicker to manufacturing. Sometimes we have monoblock, optimized design, which is reduce any assembly, any bolting or welding, so this can help us to accelerate. And it's also a repeatable and stable process. So this is make a quality repeatable and all the time. So this is helping us from this is one pillar. The second pillar, as you know, we are facing today sovereignty issue. We are facing today, how to say, supply chain issue because of geopolitical reason, because also of the economical reason. So additive manufacturing is also offering to Framatome an alternative route to stabilize our supply chain. So it's an internalization path for us for some high added value component or actions, and it's also helping us to find new manufacturing route if we have some issue. Okay, so this is quite important also for us. The third part is more in the maintenance area. So basically, with this additive manufacturing, once we qualified your process with the powder or wire for some application, then you can optimize your spare part maintenance, spare part management with on-demand spare part. So you print it when you need it, basically. You can also work on on-site recoating, so for refurbishment. You can also make some reverse engineering, where if you don't find, if the supplier has disappeared, you can scan your product and print it again. And also, of course, we can make some rapid tooling and prototyping to try things and make it quicker. The fourth pillar for us, it's the enhanced design of the component. Of course, with additive manufacturing, we have these nice shapes, complex shape that you cannot get from the old-fashioned manufacturing routes. So we believe that in the future, that today, but also in the future, we'll be using additive manufacturing to enhance the performance of the equipment and the system. And this is really important if you look to the market of the small modular reactor, advanced modular reactor, or even space, nuclear and space. This is really important. And finally, and we should not forget that we believe that additive manufacturing, it's a green industry way, it's a greener path, it's a quicker, it's a near shape application. So we believe that we can also help on this area with some green manufacturing, green industry with additive manufacturing. The market, I just wanted to show the potential market. We can, it's where the nuclear is today. So of course the long-term operation, additive manufacturing can use it to replace component, build new component, recoating, add function, decrease dosimetry for our worker. Of course, all our new build projects. So yeah, for component manufacturing, we can enhance the quality also, which is something nice, and decrease the lead time and the cost. It will be for sure a key feature for small modular reactor and advanced modular reactor with all this design enhancement that it can offer. And it's also a way of prototyping. So let's be like startups. Let's prototype. Let's try. If it's work, doesn't work. Let's see. This is a nice way to accelerate the development, mainly. And finally, to end up with this slide, I think our colleague from EDF and Sulza has already showed the most important feature here. So yesterday, we were in the proof of concept in the additive manufacturing in nuclear industry. Today, I wish I have showed you that we have multiple on-site applications, multiple opportunities that are implemented and could be implemented right now. No need to wait. So to help out all the industry on this, with EDF, with Velon, with Emerson, with our partner, we are setting up a French nuclear standard for additive manufacturing process qualification that we wish we could put on the market on the RCCM of 2026. So later on, we can use this widely, this additive manufacturing for large-scale EPR, for SMR, and we can really get the earned value expected from it. So my final message is, it's not additive manufacturing is not only a future issue; it's also present. It's in our present. So don't be scared, and let's go together through this path. So thank you for your listening. Il reste combien de temps? C'est bon? Il reste combien de temps? So if we can have a chat if you want in the other room. Okay, thank you.